Hello everybody, this is Mr. Longo, and in this video we are going to evaluate and solve trig functions using our TI-84 calculator or TI-83, whatever kind of TA you've got. Let's do this thing. So we're going to do two things with each of these problems. We are going to evaluate the function for a given x. That's incredibly simple to do. And then in part B, we are going to find the general values of x for a given f of x. That is a little bit more complicated, and that requires a little bit more skill with our calculator. Now, our calculator is going to do all the work for both of it. But for part B, there's a little bit of changes you need to do with your calculator to make this happen nicely. Okay, now we are going to round to the nearest 10,000ths, and we are going to make sure our calculator is set to radians, and then we're just going to get after it. So first thing you might want to do is check the mode of your calculator. Make sure you are in radians like I am. Third line, radian degree, make sure you are in radians. And then go to y equals and just type in sine x. Now we're going to start with a very simple example. So what we're going to do is we're going to evaluate sine of x for f of 3. And then we are going to use inverse trig to go figure out which x values will give us 0.5. Now to do that, to evaluate, is actually very simple. All we have to do is press second graph, and we just need to go to f of 3. So there's a couple of ways we can do it. We can just go to 3, take a look, and it's 0.1411. That is the answer. So we can just say that it's 0.1411. Another way you can use your table to do that is if you were to click second and then window changes you to the table set, you can go change your independent variable to ask. And then if you were to click second graph, there's nothing in the x column because you haven't asked it to do anything yet. If you type a 3, click enter, you get 0.1411. So those are two different ways you can use the table. There's another way you can do it, and that is to find your variables. Now, depending on which calculator you have will be the menus, but you click the variable, slide over to y-vars, which is function, and you want to do the equation you have it in would be y1 for the example I'm using, and then in parentheses right after it, type a 3, click enter, ta-da, you've got it. So now we have a whole bunch of different ways we can use our calculator to evaluate f of 3. But to work backwards, we need to find intersections. So if you were to just look at the sine of x, you probably have something that looks like this. And that's not exactly very easy to work with. So we are going to adjust the window according to the problem, and then of course find an intersection. So to find the intersection, of course, we're going to need to have y2 equal to 0.5, and the rest, that's way too many intersections to find. So let's play. We're going to need to change our window, and the way we're going to change our window is using our node and amplitude. So we want to know what our crest and trough are. So since we have a nothing, no d value at the end, and an amplitude of 1, we know that our node is just going to be y equals 0. And since we have an amplitude of 1, we know that our crest is going to be at a positive 1, and our trough is going to be down at a negative 1. So the highest point is 1, and the lowest point is a negative 1. So when we create our table, our crest is our y max, and our trough is our y min. Now we need to talk about our x min and our x max. To do that, we are going to use our inequality that we've used for graphing. So remember, sine and cosine go from 0 to 2 pi. But this is where we type this part of our equation in, the b and the c, but there is no change. So this part is our x min, and this would be our x max. Now again, I'm starting with a very easy equation for you so you can see what's done and how to do it. And then the next examples are going to have some more changes. So we're going to go click on our window, and as we've mentioned, our x minimum is 0. Our x maximum is 2 pi, and we want to type 2 pi using the pi button right there. Then our minimum for our y value we've stated as a -1, and the y max is a +1. And now when you graph it, it's going to be so much easier to see. Look, it's one cycle of a sine wave. Now all you need to do is find your intersections. So we have second calc, or the trace button, and number 5 is intersect, and we want to go find one of them. And then we're going to do the exact same thing and find the other one. So we know how to get close to the intersection. We just going to have to click enter 3 times. And one of our answers is 2.6180. So we have x is equal to 2.6180 plus 2 pi k. Remember, when we're 0 to something and there's this going on over here, that right here is our period. And that's why it said general values. You have to remember that in our arc, big arc versus little arc video, we talked about general values, which list all possible, versus our principal value. Now, there is more than one x value that will give us 0.5 in the sine wave. And as you can see, we've only selected one of them. But since this period is going to just continue and this is going to cycle over and over and over and repeat itself every 2 pi, that's the shortcut. We don't have to list a whole bunch of them. We do, however, have to find the other coordinate. So you would have to press second calc and slide your way over to this point and find the intersection again, which we've done before. So we second trace, number 5, intersect. And all you have to do is get close to that one now. This part sometimes takes a little while, as you can see. And then, once we get close enough to it, we're going to hit enter 3 more times. And it's going to find that it's 0.5236. So our other answer is 0.5236. plus 2 pi k. And if it's helpful for you, sketch a little graph for yourself. So that's your sine wave. Here's your y equals 0.5. And all we did was find those two intersections. And we added the period k to it because, again, we're looking for the general values. So that is the step-by-step on how we're supposed to attack this. Now, that was a very simple example. The rest of the examples are going to be a little bit more challenging. So I'm going to walk through one more with you, and then I'm going to tell you to pause the video and go try the next 2. So for number 2, we have a node. We're going to go back and talk about the node. Node is at y equals 1. But we have an amplitude of 2. So our crest, remember, is 2 above the node. So we have a crest of 3. And we have a trough, which is 2 below 1. So that's going to be a -1. Now remember, your crest and your trough are your y min and your y max. Now we need to go talk about our start and stop. So for cosine, we're going to start at 0 and end at 2 pi. Now again, that's for a standard one. In between goes our b and then our x minus c. And we have to solve for x again, like we've done before. So the first step is to divide all sides by 4. And we are going to have 0 is less than or equal to x minus pi over 2, which is less than or equal to pi over 2. And remember, in this step, from 0 to wherever we're ending after we divide out the b, that's our period. So make sure you take special note that our period is pi over 2 this time. And now we have to add pi over 2 to both sides to continue solving. So we're going to have pi over 2 is less than or equal to x, which is less than or equal to pi. Okay? That is your start and your stop, also known as your x min and your x max. So we have to go back to y equals, and this time in y1 we are going to type 2 cosine of 4 parentheses x minus pi over 2 and then we're going to add 1 at the end. And in y2 this time we are going to be evaluating or trying to find x when it's equal to a negative 0.3. So we're going to do a negative 0.3. Now as far as our window goes, we have a y minimum and y maximum we need to take with our crest and trough, and our start and stop is our x min and x max. So our x minimum is pi divided by 2, and our x maximum is pi. And then our y minimum is a negative 1 again, but our y maximum is going up to 3. And when we click graph, we have to make one little change. I forgot to close one of my parentheses. When we click graph, we should see this. Now, again, if it's helpful, give it a little sketch. So we're going to have a graph that looks like this. And we're going to have another line that comes right across over here. We need to go find these two intersections. Now, to find those two intersections, you're going to do exactly what we did before. We're just going to press second, calc, intersect, and find both of them. And that's going to give us our two x values. So x is going to be equal to, and one of them is going to be 2.1404. And the other one is going to be 2.5720. Now we have to write the general values. Now this is where you have to be careful. Remember, this now has a period of pi over 2. So this is now plus pi over 2k for both of them. That's the one part you need to be very careful with. Now, of course, evaluating what f of 4.3 is. I've showed you multiple ways to do it. Any way that you like is fine with me. You can click your second table, and we're just going to put an x value this time of 4.3 if you're on the ask feature. And you're going to get this 0.8426. The other thing you can do is use the calculator like I showed you before. So if we were to quit out of here and we were to press second enter, it'll give us the last one. And this time we would just change it to 4.3, close your parentheses, click enter, and it's going to give us the exact same answer. You probably don't want to use the standard table this time, simply because that typically does not go up by 0.1s, which you would need to. You can set your calculator to do that, but these would probably be the two faster ways of doing it. Okay, so you've seen what to do with the calculator. For the next two examples, I'm going to ask you to pause the video, try them on your own, and then click play when you're ready. I'm not going to push all the buttons in the calculator this time. That takes too long. You should know what you're doing with that part by now. So just press pause, give them a try, click play when you're ready. Let's go. Okay, so for number 3, we have a node of a -1. And we went up 9. So that would bring us up to a max of 8. And we're going to go down 9, which is going to bring us to a trough of a negative 10. That's our y max and our y min. And we had to work with the start and stop again. So from 0 is less than or equal to pi over 15 times x plus 4, which is less than or equal to 2 pi. Get rid of the pi over 15 by multiplying both sides by the reciprocal. 0 is less than or equal to x plus 4, which is less than or equal to 30. Now remember, 30 is our period. That's what's going to be added on to the end of our x's. And then we would just have to subtract 4 from both sides. So your x minimum is going to be a negative 4 in the calculator, which is less than or equal to x, which is less than or equal to 26. So you have an x minimum of a negative 4, an x maximum of 26. You have a y minimum of a negative 10 and a y maximum of 8. And you would type that in the calculator, and you probably got something that looks a little bit like this again, where we have that part. Here's our two intersections that we had to find. So for part B, evaluating with 5, you should have received the answers. X is equal to a negative 0.5158 plus our period of 30, okay? Your other intersection that you should have found would have been 7.5158 plus 30k. And for evaluating, however you chose to evaluate, whether it's with the y1 or whether it's using the ask feature of the table, whatever you chose to do, you should have f of 6.3 is equal to 6.4963. Okay, so that's what you should have had for number 3. And if you got that, great. If you did not, you might want to pause the video one more time and go retry number 4 to make sure you got that one correct. And if you did get number 4, f of 4.1, you should have received negative 6.461, and x should be equal to 11.6667 plus 32k, and we should have 22.3333 plus 32k for the second part. And again, your graph would have looked a little bit like this. We would have had our horizontal line at negative 2.5. We would have found those two intersections. You would have had a crest at negative 1, a trough at negative 7, and our start and stop would have been from 1 to 33 if you would have set up and solved everything correctly. All right, that's it for this video. This is Longo, and I'm out. See you, bye.